as a Swerve generator where you go into it, you don't set IDs, you don't configure CAN bus. You pick this device, you press verify, and it's done. Your Swerve is moving in 15 minutes after you have firmware updated all of your devices. That is 15 minutes, so you've firmware updated your devices, maybe you've named them, and then you just go through. And I'll show a little bit of that utility here. I've worked as a CSA and an FTA at a lot of events, and no one likes when a team shows up and they have put their Swerve chassis together yesterday and they have no idea what a Boolean is. So kind of to help solve that problem is when you're using our electronics, and you can kind of start doing that in gradual steps with the introduction of the FXS and the Candy, is the issues I see teams have is where their CANcoder offsets. They're not consistently calibrating them in a fixed manner. They have wheels going one way, wheels going the other way. They're adding random inverts into their software, and they're doing all these bad things in an effort to get their robot going. And then they spin 4 matches where they're not moving, they're not competing because they're trying to get their software working. And that's, how much do we pay for these matches? It's a competition in the districts is like $3,000 per match, and so that works out to about $200 per match you don't play in. So already there's a big value out here. So oh, here it is. Sweet.
I couldn't get duplicates to work.
You couldn't get duplicate to work? Oh, okay. So I'll kind of show it off here. So the idea here is that, where's my mouse? There we go. So basically you kind of talk about, this is the intro to the wizard, basically. So you have your robot all wired up, all of its CAN is good. There's no blinky orange or red lights. It's all happy. So you say, you need to give it a little bit of details. It can't figure out everything for you. It doesn't know how big your robot is. Maybe that's an idea for a future product. So you have to put in your wheel radius, your distance between your wheel to wheel, and what module you're using. From there, it knows your steering gains. It even knows how fast your robot should be. So, Corey, if you wouldn't mind going and press the new project button.
Where's that?
Right. There you go. Cool. And then go ahead and continue. And there's a lot of steps in here to safeguard you from messing up. So let's say you got your robot all wired up, but you don't realize that one of your CANcoders is unplugged or one of your encoders is unplugged. And you go through that whole thing. And if you're doing third-party utilities, they try the best they can, but there's only so much you can do without kind of going into a bit of a lot of complexity. So if one of your CANcoders is unplugged, you know the IDs, you plug the CAN bus string is, but when you actually go and drive it, now one of your wheels is all spinning the wrong way, doing all weird things, and you think, okay, it's a code problem. Let's put some negative signs here. Let's fix our offsets here. But you don't realize your CANcoder's not turned on. It does not let you get there. It tells you your CANcoder is not powered on. So this is kind of the configuration interface for it. So you basically go through each module and you select, okay, this is the controller I'm using. I'm using an FXS, and it gives you all the simple options. You can use this, yes, with your Redline motors from 10 years ago, with your mini sim, with a CTRE Electronics Minion, with the Neo, and still have your Swerve going in 15 minutes. Drive motor, you still have a lot of different options here. So go ahead and select FX. Yep, so we selected our Kraken, and we have them nicely named here to make it nice and easy. I recommend doing that. Otherwise, you can press the little blink icon, and that blink icon will actually light up the device. It'll like beep. You want to go ahead and press that? I don't know if anyone could hear it. Do it again. But that's that. And then you want to go ahead and select an encoder. Just select any encoder for me. Go ahead and select CANcoder. And yes, you could use sensors. You could use a Candy. You could use sensors plugged into the data ports or gadgeteer port of the FXS, and use an external. You could use an SRX mag encoder or some other third-party encoder. And then just go ahead and select an encoder. Let's just see what happens, okay? Scroll down. And then validate. So it's like, okay, you put all these things in. You think you've done it right, but is there a physical issue with the robot? Okay, so in third-party utilities, How do you know if they don't detect when your mechanism is binding or other mechanical issues with your robot? It has no idea because it doesn't run any validation tests. It just trusts that you did it right. And that's kind of where there's a lot of steps, there's a lot of foot guns. So you're not going to do it right 100% of the time, every single time. So what we're going to do here is you want to go ahead and start and then go ahead and enable the driver station and then just be prepared to disable just in case, but I don't expect anything super dangerous to happen. So he enabled the driver station. And then we're going to run the azimuth test. Okay, so it says enable the driver station. Go ahead and press continue. Go ahead and stop. So there, conveniently, we selected the CANcoder to actually match the configuration for this module. In this situation, the drivetrain was disabled. It did not move. It knows it didn't move. It still needs to know. It needs to know what direction the positive direction is, the negative direction is. It needs to know all this information. And that's where it solves a big foot gun is everything in FRC and kind of in the software side of things is kind of counterclockwise from the front of the motor. That's what it expects positive. That's what module states. It's what the pilot expects. It expects things in a certain format. And your module might invert that. So I believe if you're using an inverted, counterclockwise of the motor actually results in a clockwise motion of the module. And that's inverted from what you would kind of expect. And we solve all this. What you see here, that whole test, when we do the drive test, you know, the 4 modules, pretty much done. That's it. You have a working robot, it generates your code, and you just deploy the code, and you're done. So he's going to show off, let's say you select the wrong CANcoder because you have your IPs mixed up or your CAN bus mixed up. So you select the wrong CANcoder, and is the robot enabled?
It will be.
Okay. So the module's spinning, right? Everything's happy. It looks like it's doing what it's supposed to do. Go ahead and stop. And then press cancel. And it says, okay, so the encoder, it didn't move. The encoder didn't move. And that's the other big pain point in the configuration of Swerve is what happens when you think the front of your robot is because you're working with the chassis, the build team just gave you like 5 minutes to work on the robot before they get back to putting their superstructure and their elevator on it. And you don't know which orientation is front, and they're just saying get it working. And you think your front left is your front left, when actually your front left is your front right, and you have all the orientations mixed up. We protect you from that. And then let's see where we're at. 12:3. Okay, cool. Okay, so I'm going to kind of go into a little bit more detail into kind of the. Before I continue, is there any questions? Sure.
If you're just swapping one module, is there an easy way of just reconfiguring just that module, or should you be doing that manually to like take one encoder offset?
So if it's just the encoder offset, it might be easier to just do that manually. There's also a 0 CANcoder button in Tuner when you click on the CANcoder. Alternatively, for every Swerve project that gets generated, there includes a configuration file. You can import that back into Tuner and then just go back to the module, go back to the CANcoder step, and then just press validate offsets and you're done. And then you regenerate your code and it regenerates your code. Yeah, so right here, there's a little icon here that will zero the CANcoder, and all it's effectively doing is taking the current, resetting the current, grabbing the absolute position of the CANcoder, and then taking the inverse of that and making that your offset, and that's what an offset is. The big point is to make sure your modules are in the correct orientation, so you're being consistent. For our Swerve generator, we standardize on the bevel gear being into the middle of the robot, but other setups might not. Another question back there?
When you zero the firmware, when you zero the offset, is it saving the firmware or just printing the offsets?
It saves it to firmware and offset, but if your robot code overwrites it yourself because you're applying an offset somewhere else, that will overwrite it. So it's still advised to just take the offset, copy it, and put it in your robot program. Because if you're overwriting the offset yourself in code because you have a different offset, the next time you turn on your robot, it's going to reset that back. Yeah, go ahead.
Does the generator also apply PID value, or do you have to mess with that?
So the generated code does come with pre-tuned PID values. which should work out of the box. The one thing you'll notice with generated code, depending on your module, is that your robot might be a little bit jittery. So the gains aren't perfect. They're meant to be tuned. But I know of many teams who have just taken those gains, they're fine with it, because the modules are still tracking well, they're just jittery and they make noise and they don't like it. And they'll play full matches and they'll win events just with the gains as is. That's a little bit of a different story if you're trying to do Path Planner, which we actually have an example that you can just place your tuner constants, your generated project in, and then now you have a working path following just out of the box there. In that situation, your drive gains, that's much more dependent on some robot factors such as center of gravity, weight, and things like that. That needs to be much more likely to be tuned, because if you just use the stock drive gains out of the box, we don't know the weight of your robot. We could, but there's a lot of factors beyond just weight, such as wheel scrub, that impact your tracking for path following, which is really why you need to go through it with like a fine-tooth comb. An encoder that's compatible with our system, a drive motor that's compatible, and a steer motor, and this includes the FXS with the variety of configurations. You can use the generator to just get your swerve going. So the generated code will be Phoenix. I have another question in the back.
Does this not work with Spark or Spark Maxes?
The configuration utility does not work with Spark or Spark Maxes. In that situation, you still have your Neo. So instead, what I would recommend is if you have if you can, swap those out with FXS. There's more reasons beyond just tuner that you might want to swap them out. But you could just swap it with FXS, select Neo as your motor, and then tuner Swerve generator will work just fine with that. I went back to one of my old alumni teams, Team 66, not here, but go Grizzlies, and they had a old Neo robot. They swapped the Krakens, but last year they were a Neo team, and as part of some of the testing we did, I went and wired up a whole bunch of FXSs. This is a Neo 550 robot with I believe a Rev 3 bore on the end of that. Wired it all up to FXS, and after all the wiring was done, and I just named the FXS and the firmware updated, I got the swerve going in like 10 minutes. The whole thing was like an hour and a half session. Got a question in the back?
Is this compatible with different types of sort of drivetrains as well, or is it just the one that?
Yes. So if you want to go ahead and click on the drop down for it. So we have the different manufacturers. So this will ease things out. So in case you have a SES L2 or Swerve X2, it makes that very easy. But if you're running custom Swerve, so an example of this is, I know 2767 Strike Force, they're using Kraken with Minion drive, and they're using the CTRE electronic Swerve generator. Their Swerve is very, very, very custom. So in that situation, you go to custom and you enter in your drive ratio and steer ratio. And it will, that's the hard part of the approach. Keep in mind though, with the drive ratio and steer ratio, this is, if you're not sure what your ratios are, you should triple, quadruple check those. If you enter in incorrect ratios, you're going to be back to square one of, okay, your steering position is incorrect because it thinks it's going 2 turns but it's going 1 turn. Or when you go to path following with your drive ratio, it's trying to target 5 meters per second, but it's going 10 meters per second, and vice versa. Or if you have questions on kind of the mechanical or design side of our products. Go ahead.
I had a question for FXS. I remember, I think on the slide said something about plug a sensor directly into it.
Yes.
You didn't explain that.
Oh, so the FXS, you want to go back to the FXS slide, Tori? Thank you.
Too far.
Yep. So in the FXS, it has a gadget here / data port right here, and one of the pinout. This is compatible with the similar stuff that the Candy is, compatible with PWM encoders, quadrature encoders, limit switches. So if you're using, it's the same pinout as the SRX. So if you buy a mag encoder, the mag encoder comes with a gadget here baked in. You just take a ribbon cable between the two, and then boom, you're connected, and it's all absolute. If you're using a third-party encoder, the pinout might be different. Consult your manufacturer documentation. But in which case, you would either do a gadgeteer breakout board I don't recommend soldering directly to the connector because if you solder directly to the connector and you cause damage to the connector, it is not easily repairable. So wouldn't especially recommend that. But if you do that, if you're using a compatible absolute sensor, absolute PWM sensor, you can go into tuner Swerve, and one of those options there, it was Talon FXS pulse width. You would just select pulse width and then it would work. It'll do the same steps it would normally with a CANcoder, configure offsets, calibrate it and make sure its velocity and position readings are still good, and works well. And that's where, when I went to my OT66, they used a 3-board encoder that was pulse width. We broke that out, ran it to the FXS with a breakout module, got it to a breakout module, and then that just worked.
For example, you could plug that blue-board encoding of this products to the CAN.
The West Coast 3-board is a CAN-enabled encoder, so there's no PWM output. Yes. And that's and you can use a West Coast 3-board instead of a CANcoder as well. From the software side, they look identical. So in Tuner, you would just select CANcoder as well. So in Tuner, it shows up as a CANcoder as well. In your software, you just initialize a CANcoder, and it's programmable in the exact same way.
Another question.
Got another question.
I have a question about the generated Swerve constants.
Okay.
So how does that connect to Pathfinder?
So the generated path planner project, and this is actually where there's a lot of compatibility with even not just our Swerve stack, in case you wanted to use alternative Swerve stacks like MapleSim. We give you the option to generate just the tuner constants class itself, which is just basically just like a big long constants file of the characteristics of your modules and whatnot. And this gives the opportunity for third parties to create implementations baked around the plug and play. Whether or not those implementations are correct in and of themselves, your mileage may vary, but I've heard of teams using things from MapleSim to their own homebrew things where they use tuner constants, but they want to keep tuner constants, but they want to have real root control of the tracking themselves. A-Kit has a template that you can pull the tuner constants class into. All of that's available. Do note that we don't just support Java, we support C++ and Python as well. So if you are a Python or C++ team, that is fully supported. In terms of I think someone asked how Path Planner integrates into this. So while the generated project doesn't in and of itself include the hooks for Path Planner, on one of the links on the page for the generator, it shows you our example, which is just a generated robot program with Path Planner plumbed for you. Corey's taking a look here. So we have this example called Swerve with Path Planner. We also have an example called Swerve with Choreo. So Choreo is another alternative path following system. And this includes a sample path. I don't remember exactly what the path does. I think it just drives the robot in an arc, but it includes the plumbing for creating the auto builder for you for all the relative things. So all you need to do is, instead of taking the generated project, copy the template in, copy your example, your tuner constants class, and then you're done. And then that's your path following logic right there. And Corey kind of has the paths for it pulled up here in the sample. So this is what the robot program will do. Although it is currently driving through the reef.
Yeah.
So I wouldn't recommend doing that. If you manage to do that, send me a video. I want to see it, but it'd be impressive. So we're right here on the edge of our session here. 3 minutes. Any more questions? Anything about? Yeah. Go ahead.
I see on your website the CAN range has 100 to 300 centimeter range distance, and it says 1 millimeter resolution. Is that accuracy, precision? Do you have accuracy, precision data?
In terms of accuracy, I found that it's typically around 5 centimeters accurate within 1 meter, 10 centimeters accurate within 2, and then 15 centimeters accurate within 3 meters. We don't have exact formal testing on that. This is just what I've experienced so far. So
And kind of into the formal testing of that, and part of that is dependent on a lot of factors, such as your lighting, material you're detecting, and the ambient noise of the environment. Those changes your factors, and that's why we offer a, like I think it's signal strength signal, and that you can use to determine how much you want to trust that measurement. Go ahead.
I was still a bit curious about the Minion motor. So other than like size, obviously, what's the advantage compared to some say like a Kraken X40 or something?
So use case kind of is if you have something where you need very small packaging, like this is like a quarter the size of a Kraken. And you're fine with running the wires down the mechanism. So you have like, let's say a very compressed elevator or arm mechanism where you, but you have another subsystem that goes right between it and you only have like a 2.5 inch gap. That is a perfect application of a Minion. The other example of a Minion is intercompatibility with other third-party motors and the fact that it is lighter than a Kraken X60. So with it combined with an FXS, it's about similar to an X44 in weight. But if you need a mechanism where you need, you're very worried about your center of gravity, then you may need to, you can put your motor controller down low. And some people also are a big fan of having a standalone design where they want to be able to replace the controller and motor independently for whatever reasons they may have. This enables that. So if you need to swap out your Minion, you can swap it out independently of your controller and vice versa.
Even existing stock of other motors, it's also useful. You got Neos.
Yeah. So the other thing I mentioned previously was about the Boss and the mounting hole compatibility. So they're designed compatible with other motors. Another example is like for a Neo 550. If you have a Neo 550, there is the Neo 550 compatible mounting holes. You just need to make sure you draw a little bit more space for your Boss, and then you'll just plug and play.